just in case. A complex number. Let me start out with that because that's going to come up. I think I've given you this before, but just for a little reminder, if it's a complex number, guys, it takes the form of a plus bi. That's the form given in math textbooks. They say give a definition for a complex number. It looks like that. We know what that I represents. That's the imaginary part of it, units. And we know it's square root -1. We've worked with that here in the class. Now the A and the B, they must be, these must be real numbers. We just write like this with that square R. So the A and B must be real numbers, and we have the imaginary unit attached to it, and altogether that's called a complex number. So if I ask you to find the complex zeros here shortly, I'm asking for maybe some numbers that look like this. Now here's the shock. Please tell me, would you classify this, I know it's going to look strange, and a student in my 4 o'clock session was asking about this, would you accept 2 plus 3i, which looks really strange as a number? Is it a complex number? Does it fit that form? I think A in this case is what, 2, and B is 3, and of course you have the imaginary unit on there, right? If I saw this, and you said, Professor, I got this answer, can I accept this as a complex number? Well, if it takes this form, you can. Does it take this form? Yeah. No. I can make it take this form easily. Could I? Could I rewrite this and not mess it up as that? Is that the same thing as the original -4i? And did I satisfy this restriction? Are the A and the B, the 0 in my case and the 4, -4, are those real numbers? So I can classify that just by itself as a complex number. So if I get that, I'll accept it as complex. Now, the one that you might think about, may I call 6, which is a real number, for sure. It's an integer, for sure. It's positive, for sure. Can I also call it a complex number?
Yes. 6 plus 0i.
Thank you. So I can take that form A plus bi, and I heard it, rewrite 6 as, Professor, have 6 written like this. So right now in your math, at the point where you are, every number you can think of can be written as, or in the form of, A plus bi. So we're talking about complex numbers, which real numbers are complex. I had one student say, Professor, I think all math is complex. Oh my goodness. I'm talking about complex numbers, not the difficulty of the math course. He was using the word complex for that. Now guys, this imaginary unit that we've seen in this class before, I don't like it when they, I don't know who came up with the name imaginary. I know the I, that's what you guys think of. The I represents imaginary. Imaginary starts with the letter I. No, imaginary is really a number. It's just not in the real number system. Okay, so when you think of imaginary, you may think of those little imaginary friends you have. Yeah, no. It's a number. So guys, I thought I would do that, and why, here we go. Part 2, find the complex zeros of this given polynomial function. Which means, if I see that word complex, I'll put it right above it, so in case you see it on the next quiz, this says find all. They may have an I in them, they may not have an I in them. Find all of them. Now we'll start out with, and I'm going to get some help from the handout here. Guys, the function looks like this. It's a polynomial function, p of x is equal to, here goes, 2x cubed plus 11x squared plus 30x subtract 18. Now can someone quickly remind me, is this one that I worked last time or not? Or does it look fresh or new? Did we work this one? Anyone, please? Did you see this back in your notes on Monday? I'm seeing heads nod no. Okay? So good. This is what I want to work with. Now, before I jump directly into it and get some help from a student, let me go on the side here. This is number 1. Number 2. We're also going to try to solve this. P of x, another polynomial function, and this one looks like this. 4x cubed, subtract x squared, subtract 4x, plus 1. Now I've done this. This one, when I finally get back to it, how many zeros am I expecting? I gotta get them. Gotta get them. This one, well, just a professor gave me another one that has 3, right? Now, please, compare the two. We're gonna solve both. Compare the two. Can anyone tell me which one looks like it might be easier for some reason to get the 3 zeros of the two? Which one would be easier, do you think, to solve?
Second one.
Oh, why would you choose number 2 for the easier one to get to 3? Okay, smaller numbers? Okay.
The constant
Tell me again. Oh, the constant on the end?
Yeah.
Oh, I got you. This is negative 18 on this one, right? And all of a sudden over here is what? 1? And 1 doesn't have too many choices. 1 times 1. And negative 1 times negative 1. Those are the only choices for a product to give you a 1. Something else. I'm glad you guys noticed those numbers. But something else I'm hoping you can recall that would help me so much and help you if this should happen.
The group of.
Oh, hang on. Who said that? Someone said that. He says, Professor, I think the second one can be done by grouping. And you may not have to apply these rules on this handout. And when you say grouping, please tell me if I can just mark it for me. I think you want me to group by pairs and maybe group like this and like that. Is that what you have in mind? Okay, the first grouping, if you deal with just the first grouping, there's a common factor of what? X squared?
Yes.
I can pull that out and have what? 4x subtract 1. Is that true? What could I do with the second grouping?
-1.
Take out -1. Pull out -1, and something strange happens when I take -1 out on the last 2. Does it turn into this? Now, do I now have a nice common factor to take out of the entire expression? And what is that common factor? 4x subtract 1 can now be taken out of all of it. And be careful, when I take it out of the first term, this is gone. I'm left with what? X squared?
-1.
And then -1 on the end when I take it out of the second term. Oh, that's just algebra. I haven't touched that handout yet. And then I can factor further with my algebra skills. Difference of squares, x subtract 1, x plus 1, we all know that one. And then set this equal to 0. And then solve, and we know the zero product property, just split these up. Guys, we've done this so much, I'm going to go ahead and do this quickly. This is 1/4. This is 1. This is a -1. Yes or no? So my zeros, my 3 zeros for this one in no time. 1/4, 1, -1. I don't care about the order that you place those. And we're done. It's finished. Now I'm coming back to this one. This one's going to be a little bit tougher to find the 3 zeros. So I'll make a comparison here. Now, can someone be clever and tell me? Suppose across the street at the middle school, I don't think a teacher would do this to the kids over there, but suppose this was presented to the middle school kids, and that teacher asked them to factor that. Factor the original black function. Can anyone tell me, based on what we've done, what would the factored form look like if you should factor the black? Yeah, maybe we should take that field trip. Whoa. Jeez.
Would it be -2?
Whoa. Hang on.
It would be 2x
Well,
Oh, are we talking about like x minus 1/4?
Whoa, hang on. I heard x minus 1/4, Billy, hang on. So you're saying now, Professor, if you ask me now after I do all this, put this in factored form. You said, Professor, what are you doing? I'm factoring this. And Billy says, she's gonna start out with, Billy, I think I heard you say x subtract 1/4.
Yeah. X minus 1,
X minus 1,
x plus 1,
and,
x plus 1.
look at that. I would prefer one little change here to make it look better. Billy, thank you. By the way, guys, if you split up what she's just given me and find the zeros, if you split this up at this point, would you get the same zeros that we have up here?
Yes.
So she's placed this in factored form, they call it. What might look a little better than what she gave me? Yes,
Would be instead of x minus 1, just make it x.
to begin now.
Just like make it x negative x.
No, something else. Just a little minor detail that would make it look a little better. Let me give you a hint. If I should take what we have, which is good, if I should take this out right here and ask you to multiply all this together, that's algebra 1. Multiply all this together, take a little time. Can anyone tell me what the first term would look like? Just the first term. If you should expand this out or multiply those factors together, what would the first term look like? What would the first term look like? Just the first term. Is it x cubed?
Mm-hmm.
With the first term, x times x times x?
Yep.
Would that be an x cubed?
Yep.
We're supposed to get 4x cubed, if those are the correct factors. And Billy, I'm not arguing with what you gave me, but I think I need to do something with it, so I will get exactly, if I should multiply it out for a check, I'll get 4x cubed. Right now I just have x cubed. I think everyone sees I see an x cubed. I hope you see an x cubed. Go for it.
Just include a, right? Just add the 4.
Nope. Getting close. I know what you're thinking. Nope. Something else easier than that.
We're just gonna change it to 4x minus 1.
Whoa! He says, Professor, rewrite that Billy gave you, x subtract 1/4, rewrite it like this. 4x subtract 1, and leave the x subtract 1 and x plus 1, leave those like they are. By the way, does that still give me 1/4? And this still gives me 1? And negative 1? I still get the same zeros, so my zeros are fine. Now, when I multiply this out, will that first term now become what I want it to become? Would I get a 4x cubed if I multiply all the first terms together? So the guys, that's the preferred form. By the way, this is p of x in factored form. Okay, we found the zeros, we put it in factored form, and I wish I had time, we should graph it. Yeah, I am going to graph it. I want to see what a graph looks like. Can you imagine the next quiz coming up? Is spring break after the next quiz? Yeah, when you see that next quiz, you may need a week off to recover. Oh, so it's going to be a nice one. Okay, here we go. I want a quick sketch of this. Won't take much time. We got the zeros, we placed it in factored form, why not? Now I'd like to know what this thing may look like. Here we go, guys. My zeros, I found those, 1/4. Let me place those over my x-intercept. Let me place 0 here for a reference. Let me do this in case. Let me quickly place 1/4, that's this right here. X-intercept, 1 and negative 1. Say it looks like that. Those are my x-intercepts. Can you guys see from back there? Y-intercept, if I replace x by 0, I think you guys watch my y-intercept. You know how to find a y-intercept. You go back and replace all the x's by 0. What would I end up with up there? 1. So I know the graph's got to go through this point. 1 y-intercept. Let's make it quick. I don't know what else you could do like back in middle school. We had to plot points in a table, construct a table, and then plot points from a table, which is good. We just don't have the time. Can anyone describe for me in behavior of this graph? In other words, you've got to answer a couple questions for me.
As the function goes to.
As they call it in calculus, find the limits. As x gets large, what is my p of x doing? And by the way, I noticed it's what, a cube? So you got to reflect back to what was that cubic graph doing? So guys, it says x is approaching positive infinity, so I'm out here on this edge. So what should my graph be doing? Should be approaching infinity. If it is, that tells me my graph out here on this end is doing something like that. Would you guys agree? So this answer here is infinity. If I ask you to find the limit on the other side, oh, 2 here, the limit x is approaching negative infinity of p of x, should be doing the same thing as x cubed, just doing itself on the other side. And the other side, I think, is dropping down, is it? Help me out. It's doing something like this. Described as negative infinity. Is that true, guys? We got that much done right there. Now we've got to remember whether it crosses or touches. And I'll get a rough sketch of a graph. Now I notice in my factor form, that's why I had you guys to factor. Are all the outside exponents, all depends on these exponents, are all the outside exponents understood to be, in this case ones, are they all odd?
Yes.
So what should happen at odd? Yes, it should cross. So that means when I reach -1, it should cross. Now when it crosses at this point, guys, right here, it's going to eventually pick up that 1. It's got to go up and pick up 1. It may go a little higher and come back down and pick it up. Or it may go directly to it. I'll just make a quick sketch. It's got to come back down, pick that up. Now, I'm looking at it, guys. Is that what's going to happen or not?
No.
No.
Thank you. Tell me more.
You're missing a point.
I've got 1/4. So you're saying, I've seen students, are you telling me this is okay? You say, Professor, hold on. Does it drop down to here? What a cute little graph. Does it cross again?
Yes.
And how far down it drops? I don't know, you don't know. It's got to come back. Is that true?
Yes.
And then there's a rough sketch of a picture of this. This picture right there. So there's a graph, the zeros, the factored form, can't go wrong. Is that true? Absolutely. We step back and look at it. Oh, by the way, are there some local max, local mins on this graph? Yeah, there's a local max. Looks like there's a local max right here somewhere. I don't want to call it 1 because I may be off a little bit. But there's a local max in here somewhere. Is there a local min? Yeah, down in here somewhere. You have to wait till calculus shows you how to find those. Any absolute max? No. Absolute min? No. Go ahead.
We have to graph on the quiz tonight.
No. Jeez. 3.1. No. Okay. Are we okay, guys? Now, I wish they all would work out like this. I wish every one of these remaining polynomial functions would factor by grouping. And we could do this and be done in no time. Before I jump back over to one that does not, and really show you what's going to happen tonight. Before I do this, a student asked me, says, Professor, suppose I have forgotten the x cubed graph, a parent graph, that it did this, and therefore since my first term has x cubed in it, my graph should also do what that x cubed graph did, right? Maybe, Professor, I forgot how it looked. Is there another way to find the end behavior if I have forgotten the parent graph? Because the parent graph coming up shortly might be x to the 5th or x to the 7th. I don't think those were on that handout I gave you. So can anyone tell me if that should come up? And you're trying to find the limit. This is for end behavior before I leave it. Can you say, Professor, what would happen if you tried this, let's say on an x to the 5th, I'm just starting here. And you say, Professor, I don't know what an x to the 5th graph looks like. I know what an x squared looks like, it's a parabola. I know what an x cubed graph looks like, it's that. X to the fourth, I'll make it 5, make no sort of know what an X to the fourth does on the ends. This one's an X to the fifth. Can anyone tell me what you might do to describe what is happening on the ends of an X to the fifth graph? And you may say, Professor, I don't know exactly what it looks like, but is there a way to see what's happening on the ends? Go for it.
It's
Shane.
an odd function.
Okay, she said an odd function. You think all the odd functions are going to do the same thing like my x cubed did? X cubed was an odd, wasn't it? So you're saying 5 should take that same form? 7, thank you. 7 should take that same form, x to the ninth? Absolutely. And even Shane, beautiful, I love that. All the odds will. But so also, could a student say, wait, Professor, I know how to read this. I don't know what the graph looks like, x to the fifth. But this says make x get large. So if I should go to x to the fifth and replace it by a large positive number, since you're approaching positive infinity, you don't have to get too large, 10. If I replace this by 10 right here, is 10 to the fifth getting really large? 10 times 10 times 10. If I went even larger, in other words, x gets large, that larger than 10, I could try 50. I guess if I replace x by 50, that's 50 times 50 times 50 out 5 times. Is that a big number? Does that also tell you everything's getting large? So the answer should be infinity. Make sense? Now you'll say, how can I find the other end if I do not, Shane, I love what you said though. If I do not remember what the x to the fifth graph, or I do not remember what Shane gave us for the odds, and I want to find it, but this says now replace x by a negative. Maybe negative 50. That would be showing going to negative infinity, negative 50. Guys, if you put a negative 50 right there and raise it to the fifth, a negative 50 times a negative 50 times a negative 50, first are you going to end up with a negative answer? Yeah, is it going to be a big number? Yeah, with that negative prefix in front. So what do you think the response would be? Negative infinity. It's large, but in fact it's small with that negative prefix. True? So you could just look at that and think about it to get the end behavior. Woo! Now, this is where I get to have fun. This, here we go, is not as easily done as this. But yet they're asking us to find 3 zeros. The guys over here, we've got lots of space here. Now, I'm looking at my polynomial function. It's a cubic, leading coefficient 2, constant negative 18. I got some terms thrown in between. Who would like to read for me? Because since I cannot factor this one like I did the last one, it's not as easy, I need some strategies, techniques to do it. Who would like to read? I need someone to read. I will say which one from the handout. Can someone find Descartes' rule of signs? Shane. Now, Mr. Descartes, René Descartes, you guys taking physics may have heard of him. Famous mathematician. We still use this rule here. Read the rule and we'll try to apply it here. Descartes' rule of signs.
Suppose f is a polynomial function.
Hang on, which this is. Okay,
Written in standard form.
we got it.
It's broken into 2 parts. The number of positive real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f of x, or else equals that number less an even integer.
You guys are blessed to have someone to try to interpret, explain what that means. And my former student who just said he's going to Berkeley, he's going to find himself, but he's ready. He's going to find himself. When you get to that university, you read that and you decipher and find out yourself what's going on. Because that professor's probably got a little quiz for you the next day. You say, "What? I couldn't even read that. I don't know what Shane just said." I'll give praise to Descartes, the mathematician who came up with this, but that's all I know is just his name. I don't know anything about this rule. Okay, Shane, hang on now. She says, translate guys, you take your function and you start going from term to term and take note of any sign changes. So, if I move from the first term to the second term, I've got a 2, a positive 2, and a positive 11 coefficients. Is that a change, or are they both positive? They're both positive, no change. If I go from the second term to the third term, I'm going from a positive 11 to a positive 30. Any sign change? Nope. When I finally reach the end, I'm going from a 30 for that term into a negative 18. Is there a sign change? She says, Descartes says, if that happens, it tells you something about, where am I? Oh, about these 3 zeros I'm trying to find. Shane, read that very end part to me one more time.
Okay.
The part you just read to
The
me.
number of positive real zeros.
Yep.
Of f equals the number of variations in the sign of the non-zero coefficients of f of x, or else equals that number less an even integer.
Oh, are we ready for this? How many sign changes did I get? 1. That says, of those 3 zeros I'm searching for, one's going to be positive. 1 of the 3 will be positive. So that narrows it down. One's going to be positive. How about the other 2, Professor? Well, I haven't decided yet. The other 2 could be negative. But one's going to be positive for sure. Or the other 2 could be, thank you, with imaginaries in them. But for sure, what she just read to me, I'm expecting of those 3 zeros, one to be positive. Okay, here we go, guys. Write this down. We're expecting 1 positive real zero. After you get accustomed to this rule here, it's very, very easy. Okay? Now, Shane, tell me what Descartes says about the number of negative zeros of the 3 I might expect. I think maybe we get 2. We'll see if we do. What should I do?
The number of negative real zeros of f either equals the number of variations in the sign of non-zero coefficients of f of negative x.
Whoa, so they change it. He wants me to find now p of a negative x.
Or else equals that number less an even integer.
Beautiful. So that says go back to your function and now quickly replace x by negative x and rewrite it. We now want p of a negative x. Guys, if I replace x by negative x and I cube it, that's going to become a negative. This is what the rule wants me to do. Replace x by negative x here, square it, no change. Stays positive. Replace x by negative x so that 30 becomes a negative. And of course my constant stays like it is. Oh my goodness. Now do I have some sign changes here, she says. If I go from the first term to the second term, is there a sign change? From the second term to the third term, sign change. And here, no sign change. How many sign changes did I get altogether? 2. Now she says, Professor, hang on. This says you might have 2 negative real zeros. Let me just abbreviate here. And here's the catch, and I've got to be very careful. Read the very end of that, Shane, for me, the very end of that statement at the end.
Or else equals that number less an even integer.
Okay, he says if you have a 2, or a 3, or a 4, something bigger than 1, also consider that number reduced down by an even number, he says. I want to assume the even number is 2. So guys, if I take what's given to me right now and I reduce it down by 2, subtract 2 from it, that says also to consider how many negative zeros? None. So if I get a number like 2, if I can reduce it down or subtract 2 from it, and he calls this an even number, this may say, no, you might end up with none of these. Now, before I jump back in this one, suppose it may come up tonight. Suppose you counted and you had 4 sign changes. 4. Let's say you're looking for the negative real zeros, and you counted from one term to the next. He said, Professor, there's 4 changes here. Can anyone tell me what else should I consider if I follow his rule? What else could I have besides 4? I might have 2. He says subtract 2 if you can. I can. 4 subtract 2. Can I subtract 2 again? Yes, I can. What's 2 subtract 2? Might be none. Negative. So if you start out with 4, reduce it down if you can. That's what Descartes tells me to do. I didn't meet the man. I don't know. That's what he says. Okay, so if you can reduce it down by 2, go for it, and that'll give you another possibility. Now, I know why for sure here we should consider it, because I said we end up with 1 positive for real. Oh, by the way, can I reduce 1 down? No, that's why I gotta leave it, so that's set. So out of those 3 zeros, one's gonna be positive. We think the other 2 are gonna be what? Negative? And then there's a possibility, if this should happen, none are negative. Therefore, the other 2 would be what? With imaginaries. That's why you threw in that little caveat. Be careful. You meant to reduce it down again. Okay? To consider maybe the other 2 are imaginary. We haven't found them yet. We're going to find them. Yes?
Is there a way to know which of the options?
As you get accustomed to working these out, just experience. You might. Yeah. Ready, guys? Woo! Okay, here we go. I need to find them. Now we're here on the side. I'm going to use the P over Q. And I'll tell you a story about the kid in middle school that I observed when I was student teaching, or was observing as a student teacher. Remember that little story? How he was getting the answers so fast? The P on top should be a factor of that constant term. So I've got negative 18. So that says on top there, they call it P over Q in the textbook for the fraction. So on top of that fraction, list all the factors of a negative 18. And guys, I'm going to write mine like this and see if you guys will accept it. And do not let me leave anything out. Are we okay there? Those are factors of a negative 18. That's where this plus minus to cover everything. The denominator of that fraction, that's why they call it rational, ratios, fractions, should be a factor of my leading coefficient in my denominator over there. So thank goodness my coefficient is what, 2? Not too many to worry about. Plus and minus what, 1? And plus and minus what? 2. Now, who was it just asked, is there a way to guess a little bit better on this? Someone just asked a question about, is there a faster way? Shane. Here goes. I'm looking for 3 zeros. I'm hoping that when I start considering all the possibilities of this P over Q, guys, please on your handout, did they call this rational zeros theorem? Yeah. It did, so this is what I'm doing. These are rational numbers. Rational zeros, 0. I'm going to have fun with this tonight. Yes. Now, I usually don't ask students to write all the possibilities. Let me just tell you what's going on here. I'm going to list a few. You got to go through now and place each one of those top numbers over each one of those bottom numbers and form a fraction, a ratio. That's what they call it, rational function. Guys, in other words, 1 over 1, a possibility is 1. Another possibility is you place 1 over a negative 1. That might be an answer. Or 18 over 1. Oh, we're going to have fun. 18 over a negative 1. Let me get the 1 out of the way here. 1 over 2. 1 over a negative 2. I got 18 over 1, 18 over a negative 1, and how about 18 over 2? 18 over a negative 2. I don't want to leave anything out here. You guys see what I'm doing? I'm over here now. Let's put 2 over 1. Oh my goodness. 2 over negative 1. Just all the possibilities. 2 over 2. Just wait, Professor, that's the same as 1. It is. 2 over negative 2. Repeating some there. Then you go down to 9. Now, I'm not going to do this on all problems. Now here goes 9. 9 over 1. 9 over negative 1. 9 over 2. 9 over negative 2. You're not going to leave anything out. Down to 6. Do I have all those? I guess. 6. 6 over 1. Just give me an idea. 6 over negative 1. 6 over 2. 6 over negative 2. 3. Oh my goodness gracious, put it over here. Down here. 3 over 1. 3 over negative 1. 3 over 2. 3 over negative 2. I did exactly what they said to do, put P over Q, a rational zeros theorem. Right now, even if I did leave something out, I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 24 possibilities. Do I have 24 possibilities listed? Don't I? Now, here's your task. Which of those 24 would you like to try? Now, Alexandra's having a good day. Like I said, Monday, she's having a good day. She just had a good day. She loves math and all that. And she, for some reason, said, and she zoomed in on one of these 24s, and we tested, and it worked. And she's finished with her quiz, and she leaves. And my other 34 students are still seated here, looking for her. They did not try the same number she did. Just out of curiosity, does anyone have something of those 24 that I've listed, one that might, for some reason, draw attention to you, and I'll test it, and if it works, that is nice. Mr. Khan.
18 over 92.
Okay, I'll tell you ahead of time, just to save me a little time here. That is a possibility. This is negative 9, by the way. In fact, I think I would repeat some of these. That's a negative 9, right? I've already worked the problem out. To save me a little time, it's not going to check. Now, I'm saying you're right. You don't know here right now. But to save a little time, I've already tested it. Negative 9 or 18 over negative 2 will not check. Okay? But we don't know. That's the frustration. Anyone have another one? Nasia, what do you think?
1/2?
Wait, let me circle this. So you think 1/2 works?
Yes.
Let's see if this marker will work for me. Watch it not work and change it. He said, Professor, of all those 24, he's going to try 1/2. For what reason? I don't know why 1/2. Is 1/2 special for you?
No, it's just because the last number is kind of small, so if we use the big number, we're just going to weigh
He's looking at some strategies here in his mind. He said, Professor, I don't know. I'm just looking at the original function, I think, and the numbers involved. Okay, here we go. They're going to test 1/2. The guys can do it by synthetic, like we did last time. So we'll block off his 1/2. Now I'm going back to my function, and I got to jot down the coefficients and the constant. Nacio, was it 2,
11,
11,
30,
30, and what?
negative 18.
Negative 18. Here we go. Now, does anyone recall how the synthetics start? What do you always do at the very beginning? Place a 0, always. Just add those up in that first column and get a 2. Then his 1/2, you multiply these two together. And 1/2 of 2 is 1, that goes here. You add those up. In that second column, you get 12, 11 plus 1. Then here comes his 1/2 again. Multiply those two together. 1/2 of 12 is what, 6? Add those up in the third column, 36. 1/2 times 36, please tell me, is that 18? Now look at that. You get a 0 on the end. Now, sir, thank you. He's found one to work. Now, does anyone think, we got 2 more to find. Oh, by the way, is that 1/2 positive?
Yeah.
Oh, look what you did. Descartes says 1 should be positive. You found it. He found the one positive real zero that Descartes' rule says I should have. It's positive 1/2. Now the other two could be negative, so that means do not test any additional positives. That's gonna help. You found the one positive, don't test any others, they're not gonna work. So the other two may be negative, but it might be imaginary. Does anyone have a favorite negative in this mess? And I'll test it. Mr. Kahn.
2 over -2.
Wait, with 2 over a -2, that's a -1. So I'm you want me to test -1, which may work. Hang on. Now I'm gonna stack this up. Here goes. 0, 2. -1 times 2, -2. Guys, don't let me mess up here. Is that 10? And then there's just a -10 here, and we get 26, and I was hoping to get a 0. So I know that did not work, but we don't know ahead of time. I'm glad he gave me something there to test, because we do not know yet. Alexandra,
What about -9?
let's try, oh, that's a fairly good size number, let's try it. -9. 0, 2. Is that true? Then what, -18? -9 times 2, -18? And I'm afraid that's gonna be a -6, is it? Yes or no? And what's this? I think it's 54. So if I take 54 and 36, they will not sum up to a 0. But we, like I said with Mr. Conner, we did not know that's what you gotta do. Yes?
Can you just make the answers?
Not yet, not yet. I don't want that, it's too much fun here. Shane?
-3.
-3. Try -3. Here goes. 0, 2. Products of -6. Add up 6. -3 times 6. Whoa, did I do that right? Is that gonna be a -18? Is it gonna work? Nope. You've already received your acceptance to Berkeley or UCLA, and all of a sudden you're still at SMC, and they'll say, why are you still there? I haven't found the 3 zeros for that problem in Math 2, and I can't leave. Professor Ramsey says, I can't come yet. Gotta need another negative possibility. Who knows, they might be imaginary. That would be horrible if they are, because I can't list imaginaries. But are there any other negative possibilities? Don't know.
Oh, actually, there's like 2 or 3.
Con, give me another one.
-18.
A -18, I'll tell you ahead of time, I think that's gonna be too large. Even that -9 we tried was too large. Worst case scenario, it would be the other two are imaginary, Professor. I don't know yet. Yes?
Change that to 2x squared.
Oh, no, that's another story. I don't want to do that yet. I just want to get a good grasp of what is involved here. And by the way, let me do this. We know, I think we tried this and it didn't work. Is that true, guys? We did try. Well, the negative numbers, not too many are, did we try this?
Yeah.
No. Did we try -1?
Yeah.
Yeah.
Oh, we did. Oh, it didn't work. I know this thing's not gonna work.
18.
Did we try this? That's negative. Did we try -1/2?
We did not.
It may work, I don't know. You think it would?
Yeah.
If not, we'll just, no? Well, that's a possibility. This may work. Did we test -2? It may work. I didn't test it. Let me test -2 right quickly. I don't know if it's gonna work myself right now.
It's gonna work.
Oh, it does?
Yeah.
Wow. Okay, -2. Here goes. 0, 2, -4, is that 8? Here it goes. Check and see if this is correct here, guys.
-16.
Is that 8 and -16? Is it gonna work? What's that, Professor? Yes, I gotta move on here shortly. Negative 2, wait now.
3 over 2.
3 over 2? Where is 3 over 2? Negative 3 over 2. Down here? You mean the last one might work? The last possibility?
Yeah.
Oh my goodness, I don't know. Negative 3 halves. Alexander. Here it goes. 0, 2. You multiply these two together, the 2's will cancel. Give me a negative what? 3? Is that 9? Help me out. True? Yeah, I gotta stop. I don't see taking the negative 3 halves times 9 and get some crazy with a fraction in it. That's not gonna work. Now, some of you guys know where I'm going. Did you guys who said go ahead and set something equal to 0, go ahead and solve it? Did you guys get answers?
Yeah.
Were they imaginary?
Yes.
That's the game I was playing. Descartes says expect 2. I mean, we're testing. I'm not going to test any more negatives. We're getting a little tired of testing all the negatives. This right here says, no, Descartes, I did not find that to happen. Well, he says, well, maybe there are none. Well, I think maybe there are none. Now, my students are saying, Professor, without that additional testing, so we can move on. After you test the first one, oh, right here, true?
Yeah.
Now, the other day, Monday, this was a cubic, wasn't it? So the 3 zeros, I've discovered 1. And if it's a cubic and I've already found 1 to work, does it now drop down to 2 zeros are remaining? Which is a quadratic.
Yes.
So this must represent a quadratic, these coefficients. That looks like this. And I can solve that quadratic, no addition, no testing needed. Divide by 2, division by 2 would help. X squared plus what? 6x
Yeah.
plus 18? Don't let me make a mistake. You guys who have done it ahead of time. Is that true?
Yeah.
Okay. Oh my goodness, circle factor. Okay, so x is equal to, here goes my quadratic formula. What is that, negative 6?
Yes.
Plus minus square root, I'll be careful, b squared is 36. Subtract 4 times a, which is 1. C is 18 all over 2. So we're going to end up with negative 6 plus minus. Guys, underneath there is 36 subtract 72. Negative 36. All over 2. Better expressed as negative 6 plus minus. How can you, this is right here is what? 6i. The imaginary comes in. All over 2, and then I could reduce down by dividing by 2. And guys, if I divide all those by 2, I got negative 3 what? Plus minus 3i. Oh my goodness. No one in this class saw me list over here as a possibility, negative 3 plus 3i. Did I? No. So the imaginaries, you can't find them by listing. Okay, let me go back. Let me see what I've done here. Okay, here we go. Let me list, guys, over here. This is where we here. The zeros came out to be 2. 1/2. 1/2. And then we got what? Negative 3 plus 3i. And what? Negative 3 minus 3i. Do we agree? Those are my 3 zeros. Okay. I gotta watch my time here, or I'll get all carried away. Now, someone in this clever class, you saw what I did after I found the 3 zeros on the easier one. We found the 3 zeros on this one to be this, which by grouping was beautiful. And then I think I asked you guys to factor, and Billy helped me out here, and we changed it a little bit. I actually have the factored form of this. It's been factored now. I want the same thing here. I've got the zero staring at me. So can someone help me out now on the side here and place p of x in complete factored form on this function?
Let's do this one.
What do you think, guys? I got put in factored form. It might look a little strange, and I'm looking back to make sure. Let's make a comparison here. We got all that done. We do. What else? Okay. Okay. This. I think, is this the original function? Now I want to know what it looks like in factored form. I bet those kids across the street can do this. The teachers say factor this. No, they're, Okay, I want that factored. Can someone help me out? How would you get to 1/2? I hope you would write like this. Would that finally lead me to 1/2? And 1/2 is one of the zeros. Now, someone clever, tell me, and I mean, you gotta be clever. A factor that will give you this.
X plus
Oh, hang on. X,
plus
or plus 3.
minus 3i.
Whoa. Whoa. Now, I want to check it here in a second. Now, I've got one more factor. Can anyone tell me the factor associated to get this?
Plus 3 plus 3.
Tell me again. Tell me again.
X plus 3
X plus 3
plus 3i.
plus 3i. Now let me check and see if those factors would work for me. Guys, if I split this up, there's no problem here. If I set this equal to 0, just a little check. Will I end up with 1/2, as we said you should? Now the one strange was, that student gave me, Professor, if you take this strange one and do the same thing, set it equal to 0, and solve for x, which merely says move some terms over, will you end up with -3 plus 3i? And the last one, if it was given to me correctly, take this factor, set it equal to 0, merely move some terms over, will you end up with that? Which I think was this. So the students gave it to me correctly. Right? Does it check? Does it check, guys? Now here's what I want. I don't want I's in the answer. No, I don't want the I's in the final. I love this. I give you a big chunk of partial credit. But I want it to look more like what we had back here somewhere. Here it is. This one looked like this. There were no I's in there. Now I understand why there's I's in this one because we had some imaginary answers. But I would like for someone to give me a clever idea. How can I clean this up? Guys, it looks nice though. Clean this up and get rid of those I's. You'll be shocked how easy it is. I don't want the I's in there. I want all real numbers. Oh, no. Nope. You'll be shocked how easy it will be for me to rid this thing of those I's and rewrite this as you probably would have seen it written in the textbook to begin with. They're never going to write I's in there. Let's get rid of those I's. Any ideas? Anyone want to be exempt from the quiz?
Sum of 2 squared.
Give me an idea.
X squared plus I.
Go to, who's talking?
Me?
Okay, tell me more.
Sum of 2 squares.
No. Who's going to take a quiz?
Oh, worth a
Yeah,
shot.
you're going to take a quiz.
Worth a shot.
Now, I've had students that say, Professor, if I'm desperate and we want to get rid of those I's, might I try just to go here and multiply all this mess out? Well, this one has no I in it. I'm not worried about it. It's good. I'll leave 2x minus 1. It's these two. A clever way to get rid of the I's, I could go through and multiply everything by x, by 3, by -3i, then collect some terms. Some of those terms may cancel. And that long multiplication would finally clear it up. I think the best way to do this. Let's think of, and be clever, think of the last two as looking like that. And see if you guys would agree. Does this take the form of A subtract B times A plus B? Is that what that looks like the way I grouped it? A minus B times A plus B. Just be a little clever. Please tell me from across the street, what is A minus B times A plus B equal to? Across the street, what's it equal to? A squared minus B squared. Difference of squares. Is that true? Now, what was my A? The way I grouped, my A was representing x plus 3. That says this is x plus 3 squared. Subtract, what's acting as my B? 3i. 3i squared. Now I can do this. This, x plus 3 times x plus 3, it's not x squared plus 9. What is x plus 3 times x plus 3? X squared, tell me more, plus 6x plus 9. Is that true? Of course it is. Now, can anyone tell me what 3i squared, there's a minus there, x squared plus 6x minus, plus 9, minus, what's 3i squared? I know what it looks like, and you know what it looks like. It looks like this. Can you do a little bit better and get rid of that I? What's I squared equivalent to? What's I squared equivalent to? Don't scare me. Don't scare me. Is I this? What on earth would you get if you square it? Yeah, the square root drops off and leaves you what? -1. And I squared equivalent to -1. So it says, Professor, down here, this is -1. That's the I squared. In fact, right here, up here, put up here. This becomes 9 times -1. This is -9, goes here. Everyone follow what I did? And now all together, all this business, I think you're going to end up with like what? X squared plus what? 6x, oh, this is what? Plus 18. Yes or no? I thought maybe the 9s would cancel, but they don't. Is that true? Well, got all be quiet. I know what you're thinking there, Professor, whatever you say. Is that true?
Yeah.
Now, if I say put in factored form, hang on. You say, Professor, if you'll put in factored form now, and you use the green again, I'm leaving the 2x subtract 1 alone. That's beautiful. No i's. Now, all this business is now this. If I have no mistake, and there's p of x in complete factored form and no I. And the other one has p of x in complete factored form with an I. It all depends whether they want the I or not the I. How's that look? Does that look scary? I told you guys the other day, chapter 3 is actually what I consider the beginning of pre-calc. This is the beginning. This is the beginning. Now, I wish I had time. I'm looking at my time right now. If would be a shame if this doesn't work. If all this work is correct, here goes, guys. Am I ready for this? Yes, I am ready for this. I'm going to actually multiply this out like an algebra 1 problem. Just a little check. I'm going to multiply that out of there. The way I'm going to do it, I'm going to distribute the 2x on each one of these. Now, someone help me out here. So 2x times x squared is what? 2x cubed? I'm going to check it. 2x times 6x, 12x squared, thank you. 2x times 18x, 18, is that 36x? Is that true?
Yes.
Then go back out, now you distribute the -1 on each one of those. That would be a negative what? Negative x squared, let me stack those up.
Negative x squared, what, negative 6x? Negative 18? Is that true? Let's go through and multiply down like an algebra 1 problem. Collect like terms. I got 2x cubed. The squares put together is 11. The x's put together is 30. And I got a constant of a negative 18. Please, I'll go back. Is that the original? Back here. Oh, if I had messed up, I was gonna really keep. Is that the original?
Doesn't that one say?
Ignacio, don't scare me. Is that the original, guys? Was it?
Oh, never mind. I was looking at.
Oh, don't scare me. So I'm not like that. It checks. It checks. And I see right now by your looks, I say, whoa, Professor, this is, whoa, this is gonna be a little crazy. Yeah.
A question, do we have to do all of this extra work when we have x squared plus 6x?
Beautiful. That's the next one I was gonna make. You're saying, Professor, you went through all this business, but I sort of saw that coming out down here earlier. X squared plus 6x plus 18. Did that come out sort of in my work earlier? And then all of a sudden, Shane says, Professor, it's here again. Wasn't it? Up here. Okay. It did, please tell me, it did check, didn't it?
Yeah.
I don't want to leave for the weekend and not realize it checked. Okay, it checks. Now, I'm looking at my time here. Get ready. Get ready. I've got rational zeros here. We've got Descartes' rule of signs. We've got all that imaginary business going on. All that business going on. And here we go. I'd love to sketch this. But I didn't sketch this one, did I?
No.
Oh, I'd love to sketch it, but we're not. Here we go. This will take me right up to the little 10-minute break. Don't get too frustrated with this. We'll get some practice. Guys, my next one, let me see what it looks like. Oh my goodness. Hang on. Oh. Here goes. P of x is equal to this. 3x to the fourth plus 5x cubed plus 25x squared. And notice everything is given to me here. 45x subtract 18. Make sure I have all that copied out correctly. There we go. Now, how many zeros am I expecting? I gotta get 4. Your quiz next week, if you see a 10, you can't walk out here unless you give me 10 zeros. Hannah says, no way, Professor. Yeah, if you see a 10, you gotta get 10 zeros. I usually go up to my max, usually I go up to a 5. I'll usually go up to a 5, and actually let me find 5. Rather than anything beyond 5, it's going to take too much time. Guys, this one's 4. Shane, let's do this. We'll set you up here, guys. Let's use Descartes' rule of signs. Now, quickly, if you look at sign changes from one term to the next, how many sign changes do you see in the original function? 1. That says one of the 4 zeros is positive. Okay, so this says you're going to have one positive real zero. You get partial credit for all of this. I realize it's lengthy. Very lengthy. One positive real zero. Well, that means we have 3 others. That's 4 altogether. Now, those 3 others might be mixed. I don't know. So let's try to find how many of those 3 might be negative. How do we do it? We go up here and find P of what? Negative x. So replace x by negative x. Hey guys, here goes. If I replace x by negative x raised to the 4th, stays like it is. Replace x by negative x, cube it, comes a negative. X by negative X, when you square it, stays the same. Replace X in the 45 there, comes a negative. And of course, you got your constant on the end. Is that true? Now let's count the sign changes. There's one here. There's one here, sign changes. One here, and none there. So what does it tell me? 3 or 1. So I can have 3 or 1 negative. If I follow the rule. 0. Now, before we take a break. Suppose I go through the routine, we're going to do this after the break. I'm going to set you up for it. Suppose I do start the routine of trying to find those 4 zeros, and sure enough, we look out, we find the one positive that's guaranteed. We'll check for positive first, that's guaranteed. 1 to 4 should be positive, I'll try to find the positive next. And all of a sudden, I'll start checking all the negatives, and I find only 1 works, not 3. I've tested all my negative possibilities, and all of a sudden you say, Professor, just 1 negative 0 is there. So that means 1 positive, 1 negative, and I'm expecting 4 altogether. Where are the other 2? Imaginary. I got what? A minute. A minute. I'm not going to do much more with this, guys. We'll save it for after the break. And you're probably sitting there thinking, Professor, you can save this until next month. Wow, this is crazy. Okay, guys, here goes. That's the possibilities, and we're going to take a break. I will not test yet. Rational zeros theorem, on top list all the factors of that again. Negative 18. Plus minus 1, plus minus 18, plus minus 2, plus minus 9, plus minus 3, plus minus 6. Leading coefficient, 3. List all my factors of 3 in my denominator, plus minus 1, think there's not too many. Now I'm not going to list possibilities here, I'm going to ask you guys just to look and choose one. Now, just out of curiosity, we're going to close down, take a break. You would have to do this now. You bring down your coefficients, 3, 5, 25, 45, negative 18. Just out of curiosity. And we'll stop. Does anyone think, without me listing all the possibilities, like I was listing all those possibilities over there, just by observing, does anyone have a number there that you think, Professor, maybe you may want to search for the positive one first? Because there's 1 positive for sure. Does anyone have a positive possibility coming out that you think might check? Oh, you did negative 1.
No, I got like negative number.
Oh, okay. Did you test a positive yet?
No.
Does anyone think they have a positive possibility, like 1 over 1 that's positive, 18 over 1, that's too big but it's positive, 2 over 1 may work, 9 over 1, a little large, 3 over 1, 6 over 1. Is that true, guys? Does anyone want to try one that you think that you might see as a positive, real 0 that might work? Mr. Khan?
6.
6? Who knows, it may work. 6, there you go. If I see it's going to not work early on, I'll stop. 3, oh, I get an 18. That's going to be a 23. Oh, those numbers are going to get too large. 6 is not going to work. And as I said, we're going to take a break. We are. Now, I thought maybe someone would list one of the positive that might work.
1/3.
1/3? Oh, by the way, is 1/3 possibility? It is, right there. Yes over this. Okay, Ignacio, let's hope we get a break here. 0, 3, 1/3 of 3 is 1, that's 6. 1/3 of 6 is 2, that's 27. 1/3 of 27 is 9. 45 plus 9 is 54. 1/3 of 54 is 18. Thank you, Ignacio. Now, Billy, before we take a break, since he was nice enough to find one for us, I know not to test any other positives. Descartes says there's only one here. And he found it for us, 1/3. So I'm not testing anything else positive. So the other 3, oh boy, they might be mixed here. So we'll find the other 3 after break. Is this a lengthy process, guys? It is. Okay, take a 10-minute break, plus we got a little quiz coming up near the end of the class. Okay.